Scene 1, the Psi Impact Illusion. Opening shot of a highly polished, rotating heavy leather-bound journal. Suddenly, digital overlays of SCI impact factor, 45.2, citations, 10,000+, and gold glitter stars explode onto the screen, gradually fading into a cold, dark gray empty classroom. Bold text on screen, consensus is not equal to important. What makes scientific research truly important? If you ask a modern university dean, they will point to the SCI impact factor. If you ask a journal editor, they will show you citation statistics. But modern science has contracted a fatal systemic disease: we have confused consensus with importance. The result? Over 90% to 95% of papers published in prestigious top-tier journals are merely derivative, comfortable noise, safe, incremental, and ultimately dead on arrival. Scene 2, the real value of truth. Smooth transition to a blackboard divided into two sides. Left, impedance matching theory surrounded by hundreds of cited tags, looking crowded but hollow. Right, wave mechanics theory, standing entirely alone in the dark under a single bright spotlight. True physical value is independent of the herd mentality. Think of wave physics. As the great mathematician Maurice Kline wrote in 1972, history teaches us that many subjects which aroused tremendous enthusiasm and engaged the attention of the best mathematicians ultimately faded into oblivion. Indeed, one of the interesting questions that history answers is what survives. History makes its own and sounder evaluations. Famous Chinese economists also warned us. Zhang Weiying famously declared, "Innovation is an idea that the majority of people do not agree with. If everyone agrees, it is merely common sense, not innovation." And Xiaonian warned, "Innovation has no sudden windfalls, chasing a windfall is the very antithesis of creation." Scene 3, in science, there are no small matters. A magnifying glass focused on the edge of a thin metallic film. The display shows electromagnetic wave vectors reflection loss, RL. A visual flowchart shows how expanding this single mathematical outlier cracks open the 50-year-old impedance matching theory. Never look down on an anomaly because it seems small. A microscopic physical mismatch is often the seismic fault line of an entire paradigm. In our research, we chose not to let go of a seemingly trivial anomaly that mainstream reviewers called an unimportant cosmetic detail. Why is it that when microwaves enter a film backing, the thicker matching film actually leads to a smaller and better reflection loss, RL? We held onto this thread, refusing to let go. Ultimately, the small question unburied a giant 50-year confusion inside materials science: the fundamental category error between a film properties and inherent materials properties. We demolished the classic microwave impedance matching theory and laid the foundations of the wave mechanics theory. Even Erwin Schrödinger's historic breakthrough was originally born of a single spark. He merely incorporated wave-particle duality into classical wave equations. From that single spark of conceptual connection, driven purely by mathematical logic, the grand temple of quantum mechanics was constructed. Scene 4, logic trumps massive volumes of data. Stylized historic imagery of Galileo standing in deep contemplation. A split screen shows a massive pile of random laboratory charts versus a single, elegant line of mathematical proof. In modern research, scholars believe that if they pile up hundreds of tables and run thousands of characterizations, their science becomes important. This is a delusion. Raw experimental data without a guiding logical spine is merely a high-tech junk heap. Without Ernest Rutherford's airtight logical deduction of the atomic nucleus, his alpha scattering experiment data would still be just an unorganized, forgotten table in an old logbook. If physicists had not logically derived the spin of electrons through the movement of charged particles in non-uniform magnetic fields, spectral splitting would still be an unexplained mess. Chemistry itself was nothing but alchemy, until Dalton and others elevated raw laboratory measurements into laws of mass conservation and definite proportions, and finally into atomic molecular logic. Let us look at Galileo. Galileo likely never dropped lead balls from the Leaning Tower of Pisa. He won his battle through pure, airtight theoretical contemplation. Galileo asked a brilliant logical question: if heavy objects fall faster and light objects fall slower, what happens if we tie them together? If we tie them together, the lighter object should pull the heavier object, acting as a brake. the whole combination should fall slower than the heavy object alone. But the combined weight of both objects is greater than the heavy object alone, so the whole combined pair should fall faster than the heavy object alone. This is an absolute, unavoidable logical paradox. The only consistent logical resolution is that heavy and light objects must fall at the exact same velocity. Nature will never tolerate self-contradictions in mathematical logic. If a theory is logically clean and mathematically secure, physical experiments will eventually catch up, just as astronauts proved when they dropped a feather and a steel hammer in the vacuum of the moon, watching them hit the dust in simultaneous glory. Scene 5, Outro. Science is not a high-status elite club. It is not an athletic race to gather citations and secure administrative hats. It is a relentless, pure-hearted pursuit of the physical universe, tested by mathematical logic. Go visit the Substack articles linked below to read LIU'S full, unedited critical treatises on physics, citation games, and the wave mechanics paradigm. Let us stop policing tone and start verifying logic.